So now that we've taken a look at what alkenes and alkynes are, we're now going to proceed to taking a look at some modifications in the way we go about naming these molecules. So the very first thing that we need to now take into account is now the presence of these double and triple bonds. And so what do we do? So if I was to draw a molecule at this point in time, I'm going to draw the expanded structural formula. And so in this case over here, I'm going to draw this one. And so you can see at this point in time that I have this double bond that is in this 5-carbon chain. Now, if I was to draw this in a condensed fashion, it could look something like this. Okay, whereby I collapse all of the hydrogens together, and this are basically exactly the same thing. Or if I want to draw a line diagram, it's going to look something like this. So I'm going to have the first 2 carbons that are up here, and then I have the next one. So this is my 1, 2, and 3. So this is 1, 2, and 3. So how do I go about representing this double bond? And so what I end up doing is I'm going to draw a line to my 4th carbon, and then I just draw a double line over here. And then I'm going to finish off with the last carbon. So this is my 1, 2, 3, 4, 5. And it's the same 1, 2, 3, 4, 5. And then in this case, I have 1, 2, 3, and then a double bond. So 1, 2, 3, and then here's my double bond. So all of these are the same representation for that double bond in this carbon chain. So if we were to take a look here, we now need to work on figuring out how to identify the location of this double bond. And so in this case over here, we need to, again, number our carbons off. So I can go 1, 2, 3, 4, 5, or 1, 2, 3, 4, and 5. So in this case, going from left to right, you can see that my double bond is found between the 3rd and the 4th carbons, but going from right to left, it's found between the 2nd and the 3rd. And so in this case, this is going to be my preferred direction. Now, when I go about identifying its location, we always go back to the same rule as we had before, which is we try to give it the lowest carbon number possible. And so in this case over here, we are going to say that this double bond is going to be at the 2nd carbon, which extends to the 3rd carbon. And so what I am going to write is I'm going to be writing 2 to indicate the location of where that double bond starts. And since there are 5 carbons over here, I am going to write pent. So now instead of saying ane, I now have to indicate that I have a double bond. And so instead of ane, I am now going to write ene instead. So this is 2-pentene. So giving another example over here, if I have something that looks like this, I now have 1, 2, 3, 4, 5, 6, 7. And I think it's very obvious, since this is leaning to the left, that this is going to be the direction that I'm going to be choosing. But I'm just going to go in the opposite just for thoroughness sake. So you can see that this double bond can either be between 2 and 3 or 5 and 6. So I opt for the 2 and 3, and I'm going to be choosing the 2. And so in this case over here, this is now going to be 2. Since there's 7, it's going to be heptene. Now, what if I have a triple bond? So in this case over here, if I write a triple bond, it's going to look something like this. And I'm going to have 3 bonds over here, and then I'm going to finish this off. And so if I was to write this one over here, it's going to be 1, 2, 3, 4, 5, 6. And then going in reverse, 1, 2, 3, 4, 5, 6. It doesn't make a difference which direction. And so this one here is going to now become 3, since there's 6, it's hex, but instead of an ene or an ane, because of the triple bond, I'm going to be writing yne. And so this is how we write the main chain in terms of identifying the location of the double or the triple bond.